In today's video, I will introduce USB redriver and Type-C solutions. USB is one of the most popular computing interface over the years. Since its inception in the late 90s, USB has increased the speed from 1.5 megabits per second in USB 1.x to 480 megabits per second in USB 2.0, then 5 gigabit per second in USB 3.0, and 10 gigabit per second in USB 3.1 Gen 2. In 2014, USB Type-C was introduced. Not only it can support 10 gig USB data, it can also support DisplayPort at 8.1 gigabit per second, in addition to support power delivery up to 100 watt. USB Type-C brought a lot more potential for the future of USB. In 2017, USB 3.2 by 2 is released to support dual 10 gig traffic over a single Type-C interface, providing aggregated 20 gig throughput. USB 4 is expected to release in 2019 that can support 20 gig per lane and 40 gig aggregated throughput over a single Type-C interface. All these higher data rates are only supported through Type-C. USB Type-C is a connector interface that has created a much better user experience by converging different types of USB connectors as well as video and power connectors into a single small form factor reversible Type-C connector, while retaining all the functional benefit of USB. It has three major advantages comparing to traditional Type-A or Type-B connectors. It can support up to 40 gig data throughput, while Type-A or Type-B can only support up to 10 gig. Type-C can support multiple protocols besides USB, such as DisplayPort, HDMI, Thunderbolt, etc. Last but not the least, USB Type-C can support up to 100 watt of power, comparing to 7.5 watt power in a traditional USB connector. Let's have a quick review of the USB signal format. This is important to understand how USB Type-C works. We start with USB 2.0 signals, which come with two bidirectional differential signal lines with VBus and ground. USB 3.0 keeps the USB 2.0 signal intact for backward compatibility and adding a dual simplex data path with a revised USB protocol. One dedicated unidirectional differential pair for transmit traffic and one dedicated unidirectional differential pair for receive traffic. Either USB 2.0 or SuperSpeed USB bus is active at any given time for a peripheral and function. USB Type-C is flippable interface with small form factor of less than 3 mm height. The flippability of cable is enabled through dual redundancies of pins in the port and plug. Direction through these pins is handled by muxing based on orientation. Type-C port pins contains USB 2 D+, D- data bus, USB 3 transmit receive pair, configuration channel for cable attach detection, cable orientation detection, roll detection, and current mode detection. One unused CC become VCOM to support power for active cable or adapter, VBus for cable bus power, and ground for cable ground. SBU means sideband use, which is not for USB, but is open for alternate modes such as DisplayPort over Type-C. The USB-C plug has only one set of USB 2 high-speed differential pair, and one of the CC pin is replaced by VCOM to power electronics in the cable, and the other CC pin is used to actually carry the configuration channel signals. These signals are used to determine the orientation of the cable as well as to carry USB power delivery communications. Typically, USB 2, 2D+ and D- pins are stopped at the PCB side, so USB 2 mux is not needed for USB 2 interface. There are several design considerations when selecting solutions for Type-C port. Whether the port needs to support USB data, if so, whether it is USB 2 or USB 3. Whether the port needs to support video, such as DisplayPort out mode. If there is any signal integrity issue in the system for USB 2 or USB 3 and out mode, whether to select redriver. For power delivery, whether to use CC or PD controller. If power requirement is less than 15 watt, select CC controller, otherwise use PD controller. If out mode is required, use PD controller. Due to the reversible nature of the Type-C connector with redundancy pins, switch or mux is always needed to properly design the Type-C system. USB-C switch can reduce pinout and complexity in USB controller. USB data and video switch is required in both host and device. For DP over Type-C out mode, SBU mux is also required. USB 2 mux is optional, as most design is stopped at the D+, D- lines. Another important aspect to consider is due to high-speed nature, signal integrity is very difficult to maintain over long distance. Typical high-speed transmission systems include transmit and receive. There are traces, connectors, cables between transmit CPU and receive CPU for proper communication. Maintaining signal integrity for this high-speed signal over transmission media is quite challenging. There are many factors contribute to signal integrity degradation when signal pass through these traces, connectors, and cables. Insertion loss is the most common factor, which is the loss of signal power resulting from any media in the signal path. The longer the trace or cable, the more loss incurred. Here are two examples on signal degradation. First example, signal going through the same 36-inch trace while increasing speed, so we can see how eye diagram behave with different speed level. At 250 megabits per second, the eye is very clean. Eye diagram degrades when increased speed to 2 gigabit per second. At 4 gigabit per second, the eye is almost closed, resulting a lot of bit error. At 6 gigabit per second, the eye is completely closed. System will not be able to decode the data correctly without any signal conditioning. Similarly, when 10 gig signal transfers through cable, signal degradation is also expected. The longer the cable length, the more severe the degradation. Here shows the eye diagram over 1 meter cable, 5 meter cable, and 10 meter cable. Redriver is a type of signal conditioner used to restore an attenuated input signal through equalization and gain adjustment, and retransmit the signal based on signal specification. When redriver integrates with a USB-C mux, it is called a redriver mux or active mux. The benefit of using redriver in USB design is to maintain signal integrity over long trace or cable and to improve signal quality and also enable design flexibility, improve system performance, also enable broad range of interoperability and help system to pass compliance, and as well as to extend the distance a signal can travel across long cable and the trace. USB 2.0 continue to be universal in USB-C interface. Even though the signal speed is only 480 megabit per second, the compliance requirement is very stringent. USB 2 redrivers are created to help pass compliance and extend the signal reach. TI is the only company has USB 2 redriver solution in the market today. TUSB 212 is high-performance redriver with ultra-small package of 1.6 by 1.6 mm square with back-directional redriving. Comparing to hub and retimer, redriver is much easier to design with, and has very low latency, much smaller footprint, and much lower power consumption. USB 2 redriver is the most efficient signal conditioning solution for USB 2 design needs. Another great feature on TUSP 212 is called flow-through trace routing. The device does not break D plus D minus lines. Designer can lay out the board with TUSP 212 placeholder without populating the device. If signal conditioning is needed at the end of the design cycle for compliance test or interrupt test, TUSP 212 can be easily added to the PCB without respinning the board. Enable risk-free board design with best system performance. USB 3 supports 5 gigabit per second and 10 gigabit per second data rate. Signal at this speed can degrade very easily when transmitting through long PCB trace or cable. By adding USB 3 redriver can help improve signal quality and enable long signal reach while passing compliance. Here is an example on 10 gig USB going through 12-inch trace. The eye diagram is completely closed. By adding TUSP 1002A, which is USB 3.1 Gen 2 dual-channel redriver, the eye will open up nicely with very little jitter. TUSP 522P is USB 3.1 Gen 1 dual-channel redriver. TUSP 501 is a single-channel USB 3.1 Gen 1 redriver. Both can support 5G of USB data. So how do you select the right components for your USB Type-C design? If the application only needs USB data with up to 15 watt of power charging, these are the device options. HD3SS3212 is USB 10G passive 2-to-1 switch that can route the correct USB 3 data to CPU. HD3SS3202 has the same function with smaller 1.8 by 2.6 package. TUSP 321 or TUSP 322 are CC controllers. It can provide cable orientation for switch selection so the active traffic can be routed to the CPU. TUSP 212 can be designed into USB 2 paths to ensure best USB 2 signal quality. If integrated solution is preferred, HD3SS3202 can be selected. It integrates USB 3 mux and the CC controller into a single chip to reduce the complexity and footprint. If signal conditioner is needed in the system, use TUSP 542 as 2-to-1 redriver switch for 5G data and use TUSP 1042 for 10G 2-to-1 redriver switch. Redriver switch will provide best system performance and interoperability. If greater than 15 watt power is required, together with USB data needs, we can swap the CC controller with PD controller. Use the same passive and redriver switch solution to deliver both data and power over Type-C. TUSP 422 is efficient PD-PHY, very small footprint and low power. It allows design flexibility if PD software can be integrated into CPU. TPS 65987D is highly integrated PD solution with MCU and power switches combined, supporting the latest PD spec. Special mux is required to support DisplayPort over Type-C. In source side, the mux will take 2-channel USB and 4-channel DP signal, output to 4-channel Type-C signal. Ultimo protocol is defined in PD spec, so PD controller is needed. It will instruct the mux to either output all USB or all DP into Type-C interface. It is also possible to output 2-lane USB and 2-lane DP to enable data and video simultaneously over Type-C. On the sync side, a demultiplexer is needed to distribute the Type-C data to either USB device or DP sync. HD3SS460 is a passive Ultimo mux that can be used in both source and sync applications. Typical application for DP over Type-C is to connect notebook to monitor using Type-C cable, and video can be displayed to replace DP and HDMI connector. If signal conditioning is needed, a redriver mux can be used for out-mode switching. Since redriver is typically directional, different redriver will be needed for source or sink. TUSB 546A is a redriver mux for source side supporting 5G USB and DP 1.4 at 8.1G. TUSB 1046A is pin-to-pin with TUSB 546A supporting 10G USB and 8.1G DP. On the sink side, TUSB 564 is pin-to-pin with TUSB 1064. One supports 5G USB, another supports 10G USB. Both support 8.1G DP, allow easy USB speed upgrades without redesign the system. In certain CPUs, such as from AMD, Qualcomm, and Intel, in order to reduce CPU pin count, DP and USB mux is integrated into the CPU, so only 4 lanes will be provided by the CPU. These 4 lanes can be configured either as USB or DP, or 2-lane USB or 2-lane DP, and they can be directly connected to the Type-C connector. If signal conditioner needed in Type-C interface, TUSB 544 and TUSB 1044 can be used in both source and sink side to provide better signal quality. These are bidirectional multi-protocol redrivers. Each lane can be individually configured as USB or DP based on the PD controller. PD controller will provide the negotiated pin assignment for the redriver, so the redriver will work on the correct direction, either on transmit or receive. HDMI over Type-C alternate mode is a hybrid solution. In the source side, TUSB 546A can be used to mux HDMI or USB data into Type-C interface. On the sink side, it remains HDMI connector, so no special solution is needed. TUSB 546A can support 5G USB data. If 10G USB data is required, recommend to use TUSB 1046A for HDMI over Type-C solution. SBU mux serves 2 very important functions. First, most important processors do not include the flip capability for DP-AUX signals. To achieve polarity flip, SBU mux can be used to handle this function. Second, if need to bring out certain debug information from Type-C connector, for example UART signal, SBU mux can multiplex the UART and the AUX signal into the same SBU pinout to bring more visibility of the system to the outside for analysis without opening up the system. We have 2 SBU mux. One is TS3 USB-C A420, which is 421 mux. Another is TS3 USB-C A410, which is 321 mux. By using this integrated mux, we can simplify the board layout and reduce the solution size and footprint. Here is USB-C building blocks for source application such as PC, gaming device, smartphone, tablet, EPOS, etc. We can always use TUSB 8044A USB 3 4-port hub to expand one USB port to multiple ports, and use HD3SS 3220 or HD3SS 3212 mux to enable downstream Type-C port. Or if signal conditioner is needed, use TUSB 542 or TUSB 1042 redriver switch to enable downstream Type-C ports. Use TUSB 546A, TUSB 1046A, or HD3SS460 to enable DP over Type-C, or use TUSB 544 or TUSB 1044 as Type-C redriver. We can always put TUSB 212 USB 2 redriver in USB 2 data path. In the sink side, we need to use TUSB 564, TUSB 1064, or HD3SS460 to separate DP and USB paths. USB paths can fit into TUSB 8044A 4-port hub to extend one uplink port to multiple downlink ports and use the same 2-to-1 switch to enable Type-C connector. An example to switch between two different Type A ports, USB 2 and USB 3 switch and redriver can be used. TS3 USB 2-to-1E is the highly efficient USB 2 passive switch. Adding TUSB 212 redriver in the data path can compensate any loss along the way. In USB 3 data path, HD3SS3212 can be used as USB 3 passive switch and use TUSB 522P or TUSB 1002A as a redriver depending on the speed requirement to ensure good signal integrity. The sync application is mostly seen in monitor, docking station, VR, ePOS display, etc. Here are DP over Type-C typical applications. PC, notebook, gaming devices, tablets, smartphones are source applications. Docking station, monitor, VR are usually sync applications. In addition, TUSB 544 and TUSB 1044 can be used inside the Type-C cable to make it active cable to enable longer cable length. Here is Type-C data and video mux selection guide. The parts start with HD3SS indicating passive mux. Parts start with TUSB indicating redriver mux. You can compare critical parameters to find the right device to use. All our out mode redriver devices have pin-to-pin function between 5G to 10G, and all can support DP 1.4 at 8.1 gigabit per second, enabling seamless speed upgrade. We have many reference designs in TI.com. One example is this TIDA 01620 for Type-C to DP reversible active dongle reference design. This is intended for Type-C to interconnect legacy DP interface. You can connect either Type-C laptop to DP monitor or DP laptop to Type-C monitor. Use this dongle. By adding TUSB 544, it enables better signal quality and extend the cable reach between two endpoints. We have many more technical information in TI.com. Check out our blogs and white papers in addition to the datasheet from the web. We also have many useful reference designs with complete schematic and layout with proven performance. You can leverage this reference design to save your design effort and speed up time to market cycle. For more information, please visit www.ti.com. Thank you for watching.